Hi, I'm here today to talk to you about heat transfer, specifically in air and water. We're going to begin by reviewing what heat transfer is and the three types of heat transfer, but then we'll be going more in depth into what type specifically has the most impact on our weather. Heat transfer always goes from hot to cold. There are three ways that it's transferred: radiation, conduction, and convection. This should be a review from sixth grade science. As a review, radiation is heat you feel from the sun or a campfire, for example, that travels directly to you as infrared radiation. You cannot see it, but you can feel it as heat. The big thing about radiation is that it can travel through empty space, and that is a good thing because otherwise we wouldn't be able to get energy from the sun. Conduction is the direct transfer of heat from one substance to another by touching. It works well in some solids, particularly good conductors like metals, but it's not as effective when transferring heat between liquids and gases because their molecules aren't as close together. So the whole touching process and passing energy that way is reduced in how well it works. Examples of conduction are going to be anytime things are in contact. So when your feet are on hot sand, or when you have your hands in it holding a hand warmer, a pot that is touching a stove, or heat that's passing through land on Earth. Convection is the transfer of heat by the movement of a fluid. So this is where we're talking more about liquids and gases. This convection current that ends up forming where the hot part rises and the cold part sinks down. That's kind of the main focus for today. Looking at how the three impact our atmosphere, you'll see that radiation is an impact on our atmosphere because it's how the sunlight is getting to us and is warming our ground. Convection is the process where the cool, dense air sinks down and pushes the rising warm air out of the way. Conduction is the transfer of energy from land or sea to the air above it. As we go through the rest of this presentation, I want to review some vocabulary that you've experienced before. So the atmosphere obviously is going to be the air above Earth. And as we learned the second week of school, when we talk about climate, we're talking about weather patterns for a region. So not the weather on a specific day, but what the patterns are over a longer period of time. Radiant energy is just a way of referring to the energy that travels through space from the sun. Latitude is a way of measuring how far north or south of the equator you are. The equator is at 0, and as the latitude numbers get higher, you are moving farther and farther away from the equator. Rotation, just a reminder that Earth is spinning or rotating on its axis, and that is what causes day and night, and is an important contributor in the Coriolis effect that you will learn about later. Convection currents are the circular movement of fluids caused by the rising of hotter, less dense fluid and the sinking of cooler, more dense fluid. And this is a really big factor in what we see happening with weather. Okay, so since our energy comes from the sun, we've got to start our discussion there. So it's the heat from the sun that drives our weather patterns on Earth. But the thing is that sunlight is not divided equally to all parts of Earth. Those higher latitudes further away from the equator are getting less solar energy and are often colder as a result. At the same time, we have hot air rising and cold air sinking. So where's that hot air going to be rising more? Around the equator because it's warm. Cold air sinking, we're going to see that happening more at the poles where it's cold. And this creates convection currents in the atmosphere. The same thing is happening in the ocean. The sun's rays and energy at the equator are spread out over a smaller area. They're real focused, and so the heat is more intense. But thanks to that curve of Earth's surface, you can see it by the poles that same amount of light is stretched over a larger area of land and water. And so closer to the poles, the sun rays and energy have to travel further and are spread out over a wider area, thus delivering less energy to each part. So, as we just kind of talked about, different latitudes are going to have different climates because they get different amounts of heat from the sun. At the equator, the sun's the most direct, your climate is going to be the warmest. Mid-latitudes still get a fair amount of sun over the same area, or it's the same amount of energy, but it's spread out over a larger surface area. And by the time you work your way all the way up to the poles, it's cold because the sun's area is spread out over an even larger surface area. So back to those convection currents. We see them happening in both air and water, because whether it's air or water, the warm molecules are going to rise and the colder air or water molecules are going to sink. This is seen in movement we see in the atmosphere. This is seen in currents we see in the ocean. The reason this is happening is that warm air or water has more energy, and so those particles spread out and are less dense. Less dense things are going to rise up. Cold air and water has lost some energy, and so those molecules are kind of getting closer together. That's increasing the density because you have more molecules in a small amount of space, and so they're going to end up sinking down. The atmosphere and the ocean are connected because of what's happening in each of them. This is all about the transferring of thermal energy, and it's transferred between the ocean and the atmosphere, and this impacts weather and climate. If you think about the atmospheric movements, we see the sun heating the air, hot air rises, and cold air sinks, creating those circular convection currents. The atmosphere is further heated or cooled by being in contact with ocean or land. So the land can be transferring some energy to the atmosphere right above it. Think about if you've ever, on a really hot day, been walking on maybe black pavement. Sometimes you can see how much heat energy is coming off because it almost looks like the air is wiggling. The air in that situation is getting a lot of energy from that pavement and is going to be rising up as a result. Ocean has a major influence on weather and climate. Water is able to store a lot of energy, and that ocean water absorbs more energy thanks to the high specific heat of water from the sun than the land or the air. Then that ocean, which is 75% of our surface, moves that energy around Earth through convection currents happening within the water. And we will learn a little bit later about some specific currents in the ocean that are known to affect weather in different areas. That finishes the notes for this section.